Functions, circles and exponential curves. Complete the table of values below for y is equal to plus or minus the square root of 49 minus x squared. So, when x is negative 7, x squared would be 49. So this would be the square root of 49 take away 49, which is 0. So that's just going to be 0. And the same will happen over here when x is 7. Let's go for 0 next, that's the easiest one. 49 take away 0 is 49. So the square root of 49 is 7. So this one will be plus or minus 7. If we put in negative 5, then what we end up with is 49 minus negative 5 squared, which is 49, take away 25. That's 24. So what we have is plus or minus the square root of 24. Now you shouldn't have to think too hard to see that we'll get the same thing over here when x is 5. We could simplify root 24 as a surd, but let's not worry about that here. If x is negative 3, negative 3 squared is 9. 49 take away 9 is 40. So that's plus or minus the square root of 40. Again, we could simplify that as a surd, but I'm not going to worry about that here. And here, plus or minus root 40 again. At negative 1, that will end up being 49 take away 1, which is 48. So plus or minus the square root of 48. And over here, it must be the same. Now we're asked to plot these things. Notice that we've split the plus or minus here into the positive square root and the negative square root here. And then we've got x squared plus y squared is 49. Now the reason that that's been chosen is suppose you start with y is the square root of 49 minus x squared, and we square both sides. Then bring the x squared over here, and we get x squared plus y squared equals 49. Now if you start with this one and do exactly the same steps, you end up with the same result here. So I wonder what we're going to see when we graph. So in order to do this, I'm going to make use of Desmos Graphing Calculator, which is an online calculator. So let's start with y equals the square root of 49 minus x squared. And let's just zoom out a bit so we can see it. And I can see that that is a semicircle in the upper half of the graph, so where the y values are positive. The center of the semicircle is at the origin, and the radius is 7. So let's do the second plot. So that's going to be y is minus the square root of 49 minus x squared. If we just move the keyboard out of the way, and we can see that this one is a semicircle in the bottom half of the graph, so below the x-axis, but the center is 0 and the radius is still 7. So center origin, radius 7. And the two of them together make up a complete circle. Now what happens when we do x squared plus y squared is equal to 49? We can see that that's a complete circle center at the origin, radius 7, and this green one, which is the new one that we did, overlays both of the previous two. We now want to plot the following circles and see what we see. So let's get rid of the graphs we've had so far. So we'll just delete those. And the first one that we were asked to do was x squared plus y squared equals 9. So let's just think about what this is. We have a circle, center at the origin, with a radius of 3. So I'm making a note of that, and we'll look at that when we go back out of Desmos. So let's plot the next one that we want to look at. So I'm just going to delete this one. And the next one we want was x minus 1 all squared. So x minus 1 squared. And add y plus 2 all squared. Put the square in the wrong place. So just need to get rid of that. Needs to be just outside the bracket here. And we want that equal to 25. Now if we look at this circle, the center appears to be at 1, negative 2, and the radius is 5. So the center's at 1, negative 2, radius 5. Make a note of that, and let's move on to our next one. So our next one was x plus 2. So x plus 2 all squared, and then we wanted y take away 3. So take away 3 all squared, and we want that equal to just 1. Now, the center of that is at negative 2, 3, and the radius is just 1. So we'll make a note of that for this equation. And then the last one we want to do is x plus 1 all squared, and we wanted y plus 4. So plus 4 all squared, and we want that equal to 9. And if we look at that one, negative 1, negative 4 seems to be the center, and the radius is 3. So let's go back through them. For this one, the center was at 0, 0, and the radius was 3. For this one, the center was at 1, negative 2, and the radius was equal to 5. For this one, the center was at negative 2, 3, and the radius was equal to 1. And for this one, the center was at negative 1, negative 4, and the radius was equal to 3. So it seems that the x-coordinate of the center is the value of x that makes this bracket 0. If x is 1, we have 1 minus 1 in here. And the y-coordinate of the center is the value of y that will make this bracket equal to 0. So negative 2 add 2. And that works here. So if x is negative 2, the bracket's 0. If y is 3, the bracket's 0. And here and here. And I guess we could think of this one as being x minus 0 squared plus y minus 0 squared equals 9, giving us a center at 0, 0. If we look at the radius, it's always the square root of this number. So it seems that the radius is the square root of the number over here. We want to complete the table of values for y equals 2 to the x. Let's start here. 2 to the power 0 we know is 1. 2 to the power 1 is 2. 2 squared we know is 4. 2 cubed is 8. 2 to the power 4, 2 times 2 times 2 times 2, is 16. What about 2 to the negative 1? Well, using our index laws, that's 1 over 2 to the 1, so that's a half. 2 to the negative 2 is 1 over 2 squared, so that's a quarter. And I think we can see what's happening here. This one's going to be an eighth. This one is going to be a 16th. And if we keep going that way along the table, these values of y will get smaller and smaller and smaller, but they'll never get to 0 because we're just halving all the time. There's no way it could ever get to 0. Now we want to plot y equals 2 to the x, and we want to add y equals 5 to the x to the plot and see what we notice. So let's bring Desmos up again, and we want to start with y equals 2 to the x. So we'll have 2 to the power x. And we can see the shape of this curve, and we could even just zoom in a bit. So what do we notice here? So it goes through 0, 1, so that y-intercept is something I think we should make a note of. And it gets very steep over here. But on this side, it starts to go down towards 0, as we noted when we were doing the table of values. Now it's never going to reach 0, so it's going to continue forever to get closer and closer and closer to this axis, but never touch it. The axis in that case is known as an asymptote. An asymptote is a line that a curve gets closer and closer and closer to, but never reaches. The other thing I said it was important to make a note of here was this intercept. And we'll see that that is the case when we add 5 to the x. So we're going to do that now. So y equals 5 to the power x. Now look at that one. It's much steeper over here. Always over here, the blue curve will be above the red curve. But it has the same intercept at 0, 1. And that's because 2 to the 0 equals 1. Remember, x is 0 on the y-axis. And 5 to the 0 is also equal to 1. But note over here that the blue is now below the red. And that's because if we take a value, say here, at negative 1, then 5 to the negative 1 is a fifth, or 0.2, and 2 to the negative 1 is a half, or 0.5. So over here, the blue one is below. But note, it has exactly the same asymptote. It's never ever going to reach the x-axis. We now want to plot y equals 5 to the x. Well, we already have that. And then we want to add y equals 1/5 to the x to the plot. And let's see what we notice. So we already have the 5 to the x. I'm just going to edit this one into 1/5 to the x. So a bracket, and if we just do 1 divided by 5, it turns it into a fifth on here. And we want to go to the power x. And it's added it to the graph. And this one seems to be exactly a mirror image of the 5 to the x. So what you need to note here, what's important to note, is that our 5 to the x, remember that's the blue one, that one has an asymptote as the negative part of the x-axis, but the red one has its asymptote as the positive part of the x-axis. Notice the intercepts are still here at 0, 1. So how has this worked? Well, think about the fact that 1/5 to the x could be written as 5 to the negative 1 to the x, and then using our index laws, that's 5 to the negative x. So 5 to the negative x means, for example, that when we substitute in -2, we get 5 to the negative 2, which is 5 squared, which is 25. And that's why the curve is high here. Whereas with the 5 to the x, when we substitute in 5 to the -2, we get 1 over 5 squared, which is 1 over 25, which is why the curve is down here. So it's important to note that 1/5 to the x could also be written as 5 to the negative x. And remember, 1/5 is 0.2, so it could also be written as 0.2 to the x.